This video covers the notion of correlation coefficients, but does so in a novel way. Excel and Python are used to illustrate the correlation coefficients and to build heat maps. SQL is used to build the data set in a way that is meaningful to the data. Our data includes daily commodity prices and then adds the monthly Libor rates. We then calculate correlation coefficients for each of the commodities, as well as the 1 month, 3 month, 6 month, and 12-month Libor rates. This will be a lot of fun because we can dig deep into certain parts of Excel and explore some powerful parts of Python. Correlation is a statistical measure that describes the size and direction of a relationship between two or more variables. A correlation between variables, however, does not automatically mean that the change in one variable is the cause of the change in the values of the other variable. The correlation coefficient is determined by dividing the covariance by the product of the two variables' standard deviations. Standard deviation is a measure of the dispersion of data from its average. Covariance is a measure of how two variables change together. Here is the formula for the Pearson correlation coefficient, where R is the correlation coefficient, X sub I is the values of the X variable in the sample, X bar is the mean of the values of the X variable, Y sub I the values of the Y variable in a sample, and Y bar is mean of the values of the Y variable. One way to calculate the correlation coefficient in Excel is to use the Correl function. It returns the correlation coefficient of two cell ranges. Here is an example. Equal Correl. B column then is one variable. The C column is a second variable. Here then is that Correl function in Excel. Notice here is the formula, and when we hit enter here, then we see that the correlation coefficient is 0.1927. That is the correlation between crude oil, which is in my B column, and gold, which is in my C column. 0.19 is not a very strong correlation, so we would say that those two commodities are not strongly correlated. Another way to calculate correlation is to use the Data Analysis Toolpack. Make sure that the Analysis Toolpack is installed, then go to Data on the menu and choose Data Analysis. Choose Correlation, then choose Columns and the range of data. Make sure to check the box where it says Choose Labels in the first row. Finally, choose a blank cell for the output range of all your correlation coefficients. Let's go ahead and do this in Excel. So we'll go to the Data tab and choose Data Analysis here in the far right-hand corner. We'll choose Correlation, click OK, and we'll choose our input range. Mine is from B1 to J25527. I'm going to choose Columns and Labels in the first row. I'm going to make my output range 03. When I click OK and look at it, I see my correlation matrix here. So for example, I could see that the correlation coefficient between gold and lean hogs is 0.15698. A correlation matrix is nice, but adding some color and transforming it into a heat map is even better. It's relatively easy to make a heat map in Excel so that the highest positive correlations will be more red and the inverse correlations are more blue. Something like this makes it easy for users to get an idea of the correlations at a glance. Let's make the heat map now in Excel by highlighting our number range and going to Conditional Formatting on the Home tab. I'm going to choose New Rule, and I'm going to change my lowest value number colors to a pale blue. For the highest values, I want to change it to a red. So I'll click OK, and now we see that we have a heat map, and the brightest red colors are positive correlations, and the more blue colors are negative. This is how to do a heat map in Excel. Here are the commodities in our data set. The date range goes from January of 2011 until March of 2022. They include crude oil, gold, lean hogs, lumber, cattle, platinum, sugar, soybeans, and Chicago wheat. The second part of the data set is Libor interest rates. What is Libor and how does it work? The London Interbank Offered Rate, or Libor, is the most common benchmark interest rate index used to adjust variable rate loans and credit cards. Libor is used by world banks when charging each other for short-term loans. Libor is administered by the Intercontinental Exchange, which asks major global banks how much they would charge other banks for short-term loans. As I understand it, this will change at the end of 2023, but Libor is still the standard here in 2022. Here are the monthly Libor rates that I downloaded into a spreadsheet. The columns here, B17, are the 1 month, 3 month, 6 month, and 12-month rate. They are dated as of the first of every month here in the A column. Examining correlation coefficients between each of the commodities was nice, but it might be fun to see the correlation between Libor interest rates and commodity prices. Here's a spreadsheet of the data that we'll use to analyze. The first column is the Libor date, which is always the first day of the month. And the second column is the first day of the month where a commodity had a price. If the first was on Saturday and the second is on a Sunday, then the third day of the month would be the first one that had trading data. It was tricky to grab the data for the first day of commodity trading and line that up with the first day of the month for the Libor rates. Notice here that the L, M, N, and O columns have the Libor data in them. Now, other people could probably quickly come up with an Excel method or perhaps an easier SQL method, but I used SQL and I did a method here to get the data set. We need to write some queries to combine these data sets. But just as a refresher, here is the commodities data in SQL Server. Here is the Libor data as well in SQL Server. Now, we need to write some queries so that we can get those combined from the first day of the month for Libor and the first day of trading for the commodities. Here is a query that is transformed into a view that returns the first day of each month that has commodities data. We use that view in the next query to return all the data on that first day. In the select clause here, we use the minimum trade date, and then we grouped by the year and month period, and the effect is that we grab the smallest or first day of each combination of year and month. Here is what the view returns. Now that we have a view that has the first day of each month, we will join that view with the commodities table, and we join on the dates to create another view. This view will be named First Day Data. Finally, we look to join the Libor data table with the first day data table. The complication occurs because the first day in the Libor table is always the first day of the month, but the first day of the month from the commodities table might occur on the first, second, third, or fourth day of the month. Joining two tables on non-equivalent but specifiable attributes isn't common, but it happens occasionally. To accomplish this task, a cross-join is performed in the from clause, which gives every combination of all rows from both tables. The conditions for the join are all performed here in the where clause. We look for the month of the Libor table to be equal to the month of the first day table. We also look for the year of the Libor table to be equal to the year of the first day table. We know that if it's the same month and the same year, that the number of days difference will be less than 5. So we perform a date diff to get the day condition. Notice here in the answer set that the first day of the Libor table is January 1st, and it's always the first day. But here in the commodities table, it's the 3rd of January. But we've been able to join now these two tables so that we have one row, and we can now compare commodities to Libor rates. From the view that you just made, bring the data into Excel and rearrange the columns so that your data looks like this. The first column should be trade date, followed by first day, and then each of the commodity columns. At the end of the data set, you should have the 1 month, 3 month, 6 month, and 12 month Libor columns. The same tasks can be done in Python, and once a person has basic Python skills, they will notice that it is easier and faster to accomplish the same thing. This first window is specifying all of the libraries that will be used to do these same basic tasks that we did in Excel. Make note of where you stored the CSV file that you produced in Excel, as well as the file name, and read the data into a data frame as shown here in window 2. Show the number of columns and rows in the data frame as shown here in window 3. List all the columns in the data frame and see that they look like the output as shown here in window 4. Show the first 5 rows of the data using the .head method as shown here in window 5. Build a correlation matrix using the CORR or core function as shown here in window 6. Display the correlation matrix in a heat map as shown here in window 7. I used the rainbow color scheme for this heat map, but you could use any scheme that you would like. This is what the correlation matrix looks like in the heat map. To do the first regression calculation, drop all of the null values as shown here in window 8. Window 9 specifies the dependent variable y, which is crude oil. The independent variable x was specified in window 8, and that is gold. Window 10 does the regression calculation using the stats model library, the specific function OLS, which stands for ordinary least squares. The output is printed using the model.summary command. Here is the final output. Notice that the R-squared statistic is 0.08, which means that gold has almost no effect on the price of crude oil. Remember, the dependent variable here is crude oil, and gold is the independent variable. Determining relationships between data elements is an important first step to uncovering the story. Correlation coefficients are often quite informative as to what is going on with the data. Additionally, it is vital and elementary to other statistics. Have a great time calculating correlation coefficients.